For this problem, we need to find the zeros of the function f of x equals x plus 2 squared times x minus 1 cubed times x minus 3. From the factored form, we can immediately see that there are three distinct roots. They are located at x equals negative 2, x equals positive 1, and x equals positive 3. If we draw a sketch of the graph, we can see that one root will be at negative 2, another will be at positive 1, and another will be at positive 3. Now we need to look at the multiplicities of those roots. This is an implied 1. The multiplicity of the root x equals 3 is 1. The multiplicity of the root x equals 1 is 3. And the multiplicity of the root x equals negative 2 is 2. This means that this root will be bouncy. This root will be bendy. And this root will be crossy. Lastly, we need to figure out the end behavior. Notice that in our final product, if we were to expand this entire polynomial, we would have a term of highest degree, that is x to the power of 6. X to the power of 6, and the coefficient is a positive number, and this is an even function. So the end behavior will be up and up. So this means that we should start above the x-axis, bounce here, then bend as it goes through the point x equals 1, and then go straight up through the next 0. So our end behavior is up, up. For the next problem, we have f of x equals 3x to the 4th plus 12x cubed plus 60x squared. We will factor this as 3x squared times x squared plus 4x plus 20. And this is set equal to 0 because we are trying to find the zeros. Using the zero product property, we know that either 3x squared equals 0 or x squared plus 4x plus 20 equals 0. If 3x squared equals 0, that means x equals 0. So this is already one solution. Note that this has a multiplicity of 2. Here, we have a quadratic equation that is set equal to 0. So we will use the quadratic formula to solve this. This will give us negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 20, which is 80, all over 2 times 1, which is 2. This equals negative 4 plus or minus the square root of negative 64 all over 2, which equals negative 4 plus or minus 8i all over 2. Finally, our answer is negative 2 plus or minus 4i. So there are three distinct roots: x equals 0, x equals negative 2 plus 4i, and x equals negative 2 minus 4i. Note that x equals 0 has a multiplicity of 2. So for the purposes of fulfilling the fundamental theorem of algebra, it counts twice. So we have found all 4 of our expected solutions. For number 3, please notice that this long polynomial here is equivalent to t plus 1 to the 5th using Pascal's triangle and binomial expansion. This means that this problem is t plus 1 to the 5th divided by t plus 1 to the 1st, which equals t plus 1 to the 4th. If this were expanded, this would equal t to the 4th plus 4t cubed plus 6t squared plus 4t plus 1. Notice that for problem number 4, we cannot use synthetic division because there is an x squared term in our dividend. This means we will use long division. We will write our long division, making sure to carefully copy the terms from above. And we divide by x squared plus 2. To get our first term, we will have a 7x to the third. This will give us 7x to the fifth plus 14x cubed. Notice that our 14x cubed is not a like term with 4x to the fourth, so I'm actually going to write it underneath 2x to the third because that is the like term. This means that for our next line, 4x to the fourth will come straight down, and then we will subtract these two numbers. So our next line, these will cancel out. We will get a 4x to the fourth minus 12x to the third. Next, I will add a 4x squared term. This will give us 4x to the fourth plus 8 times x squared. Notice, however, that 8x squared is not a like term with negative 12x to the third. So actually, I will write it underneath the 11x squared. What this means is that this term will come straight down, and these two terms will be subtracted. So our next line will have negative 12x to the third plus 11x squared minus 8x squared, which will be 3x squared. This means that our next term in the quotient should be negative 12x. This will get us negative 12x to the third minus 24x. But notice that once again, that does not match with our term. So I will write that off to the side so that it is under the negative 24x. So now we will have a 3x squared. And notice that this time, these two will cancel out. So we will get simply a plus 6. This means that our final term at the top should be a positive 3. We'll get a 3x squared plus 6 for a remainder of 0. So our final answer is 7x cubed plus 4x squared minus 12x plus 3. For the next problem, we attempt to draw a sketch of, whoops, I just deleted the thing that we were supposed to draw a sketch of. Okay, so we draw a sketch of the function x minus 2 times 5 minus x to the third power. So we can immediately see that there are two zeros, one at x equals 2 and one at x equals 5. This means that when we plug in 2 to the function, we get f of 2 equals 0 and f of 5 equals 0. So we will have zeros at these 2 points. Now, in terms of determining the behavior Notice that this will be a degree 4 function, or a quartic function. This means that our behavior is either going to be up, up, or down, down. Notice that we have a negative x located here. When that negative x is raised to the third power, it will be a negative x to the third term. So when we expand 5 minus x to the third power, the highest degree term will be negative x cubed. That, when multiplied by x minus 2, will give us something involving a negative x to the fourth. Since this is an even degree function with a negative coefficient, our behavior will be down, down. This means we will start below the x-axis, have a crossy x-intercept, and then we will have a bendy x-intercept at x equals 5. For number 6, notice that there are 5 zeros. Based on the appearance of each root at the 0, we can decide what a reasonable multiplicity would be. So we would have x plus 4 to an even power, so I'll just put 2, times x plus 2 to another even power, so I'll put 2 again, times x plus 1 to an odd power, times x minus 2 to the power of 1 times x minus 4 to an odd power. Notice, however, that in this expression, all of the x's are positive, which will mean that the largest degree term in our final answer will have a positive coefficient. Notice that the behavior is up, down. This means that actually we are looking for a function whose largest degree term has a negative coefficient. So we should add a negative sign in front of this. This would be our final answer. Obviously, there are other acceptable answers if you used other powers besides those powers shown, as long as they match the correct even or odd or 1, depending on the case. For number 7, to check if x cubed minus 2x squared minus 3x is divisible by x minus 3, we use the factor theorem. If it is divisible by x minus 3, the factor theorem says that f of 3 must equal 0. So we will plug the number 3 as input into the function f of x equals x cubed minus 2x squared minus 3x. If we compute f of 3, this equals 3 cubed minus 2 times 3 squared minus 3 times 3. This equals 27 minus 2 times 9, which is 18, minus 3 times 3, which is 9, which equals 0. Therefore, we know that x minus 3 is a factor of the polynomial, which means that the original polynomial is divisible by x minus 3. For question number 8, it asks what is the remainder when the polynomial 4x to the 7th minus 16x to the 5th plus 8x cubed minus 6x plus 14 is divided by x minus 1. For this, we will use the remainder theorem, which states that the remainder when a polynomial is divided by a binomial in the form x minus a is simply the value p of a. So if we calculate p of 1 by sticking 1 as x into the polynomial, we can calculate what the remainder is when the division occurs. So this will equal 4 times 1 to the 7th power minus 16 times 1 to the 5th power plus 8 times 1 cubed minus 6 times 1 plus 14. Notice that all of those will result in 1 being multiplied to some power, which is still 1. So this is 4 minus 16 plus 8 minus 6 plus 14. You do some mental math here, you will see that the answer